Now I'd like to pass the mic to Dr. Dean.
Thank you, Renee, and good morning, everyone. The first thing we can share is that the computing power is actually increasing in power form. It's not actually just a recent trend. And as always, the computing power that we are using is increasing in a power curve. So you can see in the last 10 years, it is actually a literal power curve that we have been experiencing with the computer power advancing. The second one, I think all of us will have personal experience with this. AI capabilities are accelerating at a speed that never we have seen before. Only 3 years ago, ChatGPT is a new thing. People are amazed that we can have a chatbot answering almost every question just as a human doing. And people started to discuss whether this pass a Turing test or not. Nowadays, this has already been transitioned as a productivity tool that we use every day. You can see in my presentation today, there are multiple points I actually use the Gen AI to generate something to help me to illustrate the points. And I believe every one of us is using similar technology to write email, write reports, summarize news, summarize reports and papers. So this become a daily productivity tool that we use to produce our value and generate revenue. The third thing we observe is more on the supply side. As the demand of AI increases, supply also increases in power form as well. So two things are represented in this chart. One is that the demand for compute actually grows exponentially, while the chip efficiency also grows exponentially, but it is almost as half as what we need. So the demand is actually growing twice as fast as the supply. That's why we say computing power or high performing computing is still a great opportunity in the age of AI. For agentic AI, an agent is basically some program powered by large language model. It is different from any chatbot or ChatGPT as the raw form we're using today because it leverages your existing documents and the data to make better decisions and contextual decisions. And more than that, it also calls certain software API or tool API to accomplish certain tasks. So if we say, if we think about a human process, let's say I want to order some food for lunch, I can either do it myself or I can use an agent that based on my historical ordering as a document that I store somewhere and the real-time data that pulled from apps saying that the price, the choice I have, and maybe the ratings of the different food, and the large language model will help me to make this decision and call the ordering API to order the food. The next topic I will talk about is actually a relatively newer term called physics AI. Let me first illustrate how physics AI is different from the language model, the large language model we are using as of today. And it is also different from the image or vision type of AI we are more familiar nowadays. And then I will illustrate how it is relevant to manufacturers and why this is actually the next big wave coming to you. When we talk about language model, it's actually a one-dimensional model. Large language model works in a way that it always predicts the next best word based on the previous words or tokens based on the previous tokens. So you can see here, the solid color boxes are the known words or the words that we have typed in as prompts. Large language model in the very simple form is basically predicting the next best token or next best words based on the previous ones. So some of you may have generated images using ChatGPT or using any large, generative AI model, right? So basically you can type in a sentence and the AI will generate an image for you. It is slightly more complex than language model because this become a two-dimensional thing. What vision AI do is basically predict each of the pixel based on the surrounding or based on your prompts. So it is a two-dimensional thing because the pixel is not only related to the horizontal neighbors, it is also related to the vertical or diagonal neighbors of this pixel. So as I have illustrated here, it becomes a two-dimensional model that we need to tackle. It is slightly more complex than the language model. And in terms of token counts, you may observe that if you are using the GPT model to generate an image, first of all, it takes longer for them to respond. And second, it actually costs more on the computing side to generate an image compared to generate just the text. If we move on to physics model, it will be three-dimensional. Because when we analyze physics, it is actually the three-dimensional, the space relationship about entities and how they react to each other. Actually, it can be four-dimensional as well, because in physics, not every force, not every effect will take place immediately. It may be in a timely consequences that you will see that some of the result will actually show up later here. So this is actually a four-dimensional effect in physics AI. This makes physics AI much more complex than the AI systems we are using now. So you can see this is where we are using an AI system to control this thing, what we call an inverse pendulum. This is clearly a physics system that the objective is we want to control this reversed pendulum upstream. You can see it is very difficult. There is actually a physics model behind this. People have already calculated that can do that. But this attempt is actually trying to use AI to rediscover this physics relationship that makes this inverse pendulum stay upright. Physics AI is actually rethinking productivity. It means that it will change the way that we produce, that we actually build everything, design everything completely different. I think the last one I want to touch on is AI economics. This is the way we think about scaling AI and what are the factors or how do we model the economics of AI. There are actually three different models I want to talk about. It all has a real life analogy to see how do we think about AI and how do we think about the investment in AI. The first model is utility model. So now if you use AI on token basis, you will feel like AI is, or generative AI is like the utility you use. There will be a good CapEx spending by the utility factory to train the foundational model. This cost is usually not exposed to you. However, the OpEx exposed to you is to serve intelligence to you in different forms. So the utility company may serve the electricity or water to you in different forms. The second model we have, maybe familiar to some of you, is actually a fab model. This is because it is not really fair to compare generative AI as utility, right? Because even the CapEx spending is high for utility factories. Building a generative AI model has even higher CapEx requirement to that. And finally, this is actually my favorite metaphor, and I actually agree with this model more than the previous two. It is an operation system model. Maybe it is because I'm trained as a computer scientist, the operation system just feels more familiar to me. But I also feel this is very similar to how we are using generative AI or large language model nowadays. First of all, there is increasingly complex interaction for human. So we are using generative AI in different forms, not just as a chatbot. There are apps that provides you generative AI capability. There are softwares that are running on generative AI and just give you the generated output without you seeing the prompt or seeing how it is being generated. We need to scale it up to get the maximum benefits out of it. So AI economics is actually calling for rethink scaling. for people to decide how do we use AI. So these are the three things I have talked about in the 30 minutes. If we put them together,